Hello students, welcome to MGC Learning. I am Manju Dilip. Today I am going to start with the 12th standard mathematics topic Indefinite Integration Part 2. We already studied in the previous video about algebra of integration of some standard functions, etc. So today I am going to start with the same topic, but solving some more questions in that. So first question is evaluate integral cos 2x upon sin square x into cos square x dx. So let I is equal to the given question cos 2x upon sin square x into cos square x dx. Now we can change the numerator with using this formula cos 2x is equal to cos square x minus sin square x, because the denominator is also consisting this term sin and cos, so we can convert in cos square x minus sin square x. Now we will split this numerator. There are two terms, so it can be split with this like this. So integral cos square x upon sin square x cos square x dx minus integral sin square x upon sin square x cos square x dx. Now cos square x and this cos square x cancelled, sin square x and one of the sin square x cancelled. So this will become integral 1 upon sin square x dx minus integral 1 upon cos square x dx. Integral 1 upon sin square x is cos square x dx minus integral 1 upon cos square x is sec square x dx. Now we know this integral values. So integral cosec square x dx is minus cot x and integral sec square x dx is tan x, and since it is minus here, so minus tan x plus c is the final answer for this question. Next question is evaluate integral sin x upon 1 plus sin x dx. Here again you have to apply the same procedure. So you will apply integral I is equal to integral sin x upon 1 plus sin x dx. Then since it is not 1 plus cos x or something, so we can multiply numerator and denominator with rationalization term of this denominator, that is 1 minus sin x. So integral sin x into 1 minus sin x upon 1 plus sin x into 1 minus sin x. So the numerator will become integral sin x minus sin square x, and denominator this is a plus b into a minus b format. This will become a square minus b square. And 1 minus sin square x is cos square x by fundamental identity. So you can change the denominator in the next step. So integral sin x minus sin square x upon cos square x dx. There are two terms in numerator. You can split it to two terms. So integral sin x upon cos square x dx minus integral sin square x upon cos square x dx. This will become integral sin x upon cos x into cos x. So 1 upon cos x is sec x and sin x upon cos x is tan x dx minus integral sin square x upon cos square x is tan square x dx. Now this will become integral sec x tan x dx minus integral tan square x can be written as sec square x minus 1 dx, because we don't have the direct formula of tan square x. So you can convert it into the fundamental identity using this one. Tan square x is equal to sec square x minus 1. So it will become integral sec square x minus 1. And we know the integral of this one. So the first term is integral sec x into tan x is sec x minus integral sec square x is this one. Minus into minus is plus integral 1 dx. So sec x minus integral sec square x dx is tan x plus integral 1 dx is x plus c. This is the final answer for this question. Next question is evaluate integral tan x upon sec x plus tan x dx. So this can be solved in many ways. So one is you can convert this tan x into sin x upon cos x. Similarly, sec x can be converted into 1 upon cos x, and tan x again sin x upon cos x. That way also you can solve it. Otherwise you can take the rationalization method. So you can take the term sec x minus tan x and multiplying both the numerator and denominator. So you will get like this. Then you can multiply integral tan x into sec x minus tan square x. Numerator will become like that upon this is a plus b into a minus b format. So you can write it as sec square x minus tan square x dx. And we all know that sec square x minus tan square x is 1. So the denominator will become 1 in the next step. And this can be written as integral sec x into tan x minus, you can again convert this tan square x into sec square x minus 1. So integral sec x tan x dx minus integral sec square x dx minus into minus is plus integral 1 dx. So the integral of sec x into tan x dx is sec x, minus integral of sec square x is minus tan x, plus integral 1 dx is x plus c. This is the answer for this question. Next question is, evaluate integral root of 1 plus sine 2x dx. If the question is in terms of 1 plus sine x, 1 plus sine 2x, 1 plus sine 3x, yeah, 1 plus sine 5x, etc. This pattern questions are coming, then you have to convert this 1 into cos square x plus sine square x, yeah, cos square x upon 2 plus sine square x upon 2 format, anything. Here I am taking this 2x as the angle x. So we are considering here this as x. So this question will become I is equal to integral root of cos square 2x upon 2 plus sine square 2x upon 2 plus 2 sine x upon 2x upon 2 into cos 2x upon 2. Here I am taking this 2x as x. You can take this as a sine 2x formula also. So 2 sine x cos x you will get, and in the place of 1 you can write it as cos square x plus sine square x also. Both way you can do it. But for remaining questions, if 1 plus sine 3x is coming, 1 plus 5x is coming, that time you have to consider this as one angle, that means x. So here I am considering that way. So if sine x I am considering, half angle formula will come. So here I am using that. So integral cos square 2x upon 2 plus sine square 2x upon 2 plus this is a square plus b square plus 2a into b format. So I can write this as a plus b whole square format, that is cos 2x upon 2 plus sine 2x upon 2 whole square dx. Now after coming out of this square root, it will become integral cos 2x plus sine 2x upon 2 dx. Then integral of cos 2x upon 2 to cancel, and here again 2 to cancel. So it will become integral cos x dx plus integral sin x dx. So integral cos x is sin x and integral sin x dx is minus cos x plus c. So this is the answer for this question. Next question is integral sin 4x into cos 3x dx. So let I equal to the given question. We know this formula 2 sin a into cos b is equal to sin of a plus b plus sin of a minus b. So this is similar to that. If it is the product of sin into cos, you can apply this formula and change this integration into that formula pattern. So here only this 2 is missing. So I have to introduce this 2 by multiplying and dividing. So 1 upon 2 is a constant, I can take it out. Integral 2 sin 4x into cos 3x dx. Now this is in the formula pattern. So I can apply that formula. So that is sin of a plus b plus sin of a minus b. So in this place I can replace this with sin of, in the place of a it is 4x and b it is 3x. So sin 4x plus 3x plus sin 4x minus 3x dx. That is sin in 1 upon 2 integral sin 7x plus sin 4x minus 3x is x dx. Now I can integrate. So 1 upon 2 sin 7x dx is what? 1 upon 2 is a constant. So I am taking integral for both these terms together. So integral of sin 7x is minus cos 7x upon 7. This is sin of ax plus b format. So you have to divide with that coefficient also. And integral sin x is minus cos x plus c. Now in the next step I can multiply this. So 1 upon 2 into this one will become minus cos 7x upon 2 7s are 14 minus cos x upon 2 plus c. 5. Then this is the final answer. This way also you get. This is the last answer, but just written like this. Next question is evaluate integral x upon x plus 2 dx. So in this type of question, both the numerator and denominator degrees are same. If both the degrees are same, you can adjust the numerator, that is x, like this term. So this will become, let I is equal to x plus 2 minus 2. Here I am just changing the numerator as denominator. So x plus 2 is the denominator. So I am writing that, and to cancel that I can write minus 2. Now I can split this into integral x plus 2 upon x plus 2 minus 2 upon x plus 2 dx. That's equal to integral 1 minus 2 upon x plus 2 dx. integral 1 dx minus integral 2 upon x plus 2 dx. That is integral 1 dx is what? X minus 2 is a constant, and this is 1 upon x plus 2 format, that is log mod x plus 2 plus c. This is the answer for this question. Next question is evaluate integral 5x plus 2 upon 3x minus 4 dx. So in this question, let I is equal to this one. Here again the degrees are same, but it is not easy to do like this. So we can divide this one using this format. So numerator upon denominator is equal to quotient plus r upon d format. You can convert this term. That is, here the dividend is 5x plus 2 and divisor is 3x minus 4. So I'm dividing this using this formula. So 5 upon 3 is the term. If I'm multiplying that, you will get 5x. So 5 upon 3 into this is my 5x and minus 5 4 are 20 upon 3. Now after subtraction, we are getting 2 plus 20 upon 3, that is 26 upon 3 are getting. Therefore, this numerator 5x plus 2 can be written as 5 upon 3 into 3x minus 4 plus 2 plus 2, 20 upon 3, that is the remainder. So 5x plus 2, this formula, 5x plus 2 upon 3x minus 4 is equal to 5 upon 3 into 3x minus 4 upon 3x minus 4 plus 26 upon 3 upon 3x minus 4. So 3x minus 4 and this one cancel. That you can write it as 5x plus 2 upon 3x minus 4 equal to 5 upon 3 plus 26 upon 3 upon this one. Now integrating, integral first term is constant, so 5 upon 3x plus 26 upon 3 is a constant, and this is 1 upon 3x minus 4 is log format. So 26 upon 3 log mod 3x minus 4 upon coefficient is 3 plus c. That is 5 upon 3x plus 26 upon 9 log mod 3x minus 4 plus c. So the next question is integral cos square x dx. So let I is equal to integral cos square x dx. That's equal to integral 1 plus cos 2x upon 2, because 1 plus cos 2x is equal to 2 cos square x. So integral 1 upon 2 dx plus 1 upon 2 into integral cos 2x dx you can write. So integral of 1 upon 2x, this is 1 upon 2. You can take it out actually. So x plus integral of sin cos 2x is sin 2x upon 2 plus c. So this 2, if you want, you can take it out. So 1 upon 4, this will become 2x plus sin 2x plus c. That is the answer for that question. Next question is evaluate 3 upon root of 7x minus 2 minus root of 7x minus 5 dx. This question you can use the rationalization method again. So you will multiply both numerator and denominator with root of 7x minus 2 plus root of 7x minus 5. So the numerator will become 7x minus 2 upon raised to 1 upon 2 plus this one, and denominator, this is a minus b into a plus b. So you can write it as root of 7x minus 2 whole square minus root of 7x minus 5 whole square. So 3 into this squaring, so 7x minus 2 minus 7x minus 5 it will come. So 3 into integral 7x minus 2 whole raised to 1 upon 2 plus this one, numerator as it is, and denominator 7x minus 7x will cancel, minus 2 minus into minus plus y. So minus 2 plus 5 is 3. Now in the next step, if you want, you can cancel 3. I didn't cancel here, so separated the numerator, then 3 cancelled in both the cases in first term and second term. So it will become 7x minus 2 whole raised to 3 upon 2 upon 7 into 3 upon 2 plus 7x minus 5 whole raised to 3 upon 2 upon 7 into 3 upon 2 plus c. That is this term. 3 sevens are 21 upon 2 is the denominator. If you are taking the reciprocal, you will get 2 upon 21. That is common for both the terms. And the remaining term as it is plus c. That is the answer for this question. Next is exercise question. You have to solve it. This 3 questions are here. Thank you.